This meeting is being recorded.
All right, I can hear that in the background. Well, welcome again, everyone, to the INCOSE monthly webinar in September. We have Jane Wright with us today with Transport for London. So INCOSE UK Railway Interest Group Chair Matt Gibson will introduce Jane.
Yeah, thank you, Hoki. Yeah, welcome everybody. As Hoki says, this is the INCOSE UK rig are hosting Jane today from TfL, who's going to kick off the first in a series of events we are collectively hosting with APTA and the TWG, focusing on sustainability in systems engineering. So this is part one, and Jane is going to talk to us today about how systems engineering is being used and systems thinking in carbon reduction at Transport for London. Jane has spent a lot of her time at TfL working across bus electrification and infrastructure carbon management. And she's also an Institute of Civil Engineers Carbon Champion and has been named in the list of top 50 women in engineering in this year, 2022, with the Women's Engineering Society. So we are very honoured to have Jane here today to talk to us. Without taking up any more of her time, I'll hand over to Jane.
And I will, Jane, let's see, we can share your screen. Let me stop my share. 1 second. All right, here we go. Yeah, Jane, go ahead.
Cool, perfect. Great, thanks Matt, thanks Hoki. Really lovely to be here. So I'll just share my screen and hopefully we can make a start. Okay, great. So yeah, good evening, good afternoon, good morning, everyone. Really lovely to be here, particularly with such an international audience. So as Matt said, I'm Jane, I'm a systems engineer at Transport for London. I'm really excited to be kicking off this series of sustainability webinars. I guess before I dive in, I'll just talk about the image on the page here, which is part of the Show Your Stripes initiative. So you may have seen this image before, but essentially it's trying to demonstrate through colours, apologies for those who are colourblind, that towards the right-hand side, as global temperatures, average temperature has increased, we get more red bars on the right-hand side, really trying to demonstrate that we are rapidly changing our climate and our environment, and we really need to do something about it. So hopefully I can share with you today what we're doing at Transport for London to bring systems engineering really into that position of net zero and carbon management within our organisation, and how some of the thinking is being shaped, certainly within the UK infrastructure carbon management world. Hopefully you learn something, hopefully get a few tips to take away. I know carbon management is new to everyone, so hopefully this is a nice kind of introduction with a systems engineering tilt on it. So I'll start off with talking a little bit about Transport for London for those of you who aren't familiar with the organisation, and of course because we're systems engineers, I thought I'd make a start by going through my carbon emissions requirements cascade, and what our constraints are at Transport for London, and how we're seeking to manage those carbon requirements.
1 second, Jane. Now the slide moved. Yeah, we just trying to see. Yeah, because it may have a minute delay here, but yeah, go ahead.
Okay, sure, right. I'll try and move the slide sort of ahead of time, but yeah, that's good to know. Thanks, Hoki. So I'll also then move on to talk about and introduce whole life carbon management. So kind of what does that actually mean, and ultimately who should be doing it and who should be leading it, and you can probably guess my answer to that question. I'll then talk through a couple of case studies at Transport for London, where we're trying to go next, and end with a sort of what should you do. So Transport for London is London's transport authority. So we're a sort of 20,000 strong organisation, 10,000 in operations, and 10,000 sort of back office staff, and we're responsible for managing the entire transport network across London, which is really, really exciting because it's not just rail, it's not just vehicles, it's kind of all of these things that you see on the screen here. It's how we manage our congestion charge systems for private vehicles. It's how we design and manage a kind of non-intrusive cycle hire system. We manage our ferries, we manage mobility transport as well, on-demand mobility transport. We manage heavy rail and metro rail systems. So it's the full package. It's a really complex, really exciting system. So I'm really excited to be working there, really lucky. We've got a large in-house client engineering team, so approximately 1,300 people, with probably 20 to 30 systems engineers who currently work across our major projects. So you may have heard of a little project causing a bit of trouble called Crossrail. So we've got a few engineers who were seconded into that to try and help solve some of the systems engineering problems. That will be a whole other webinar. But we've got the Northern Line extension, Silvertown Tunnel, all these major projects our systems engineers work across. So if we start to focus in on carbon emissions, so what are our requirements and constraints? I'm not going to dwell too much on this because hopefully lots of people on the call are aware, we're in a really critical point in terms of what humanity needs to be doing about carbon emissions, and really as planet Earth, through the Paris Agreement and through scientific research, we know we need to be getting to net zero by 2050, and by this I mean that all of our carbon emissions need to be balanced by carbon removals. So we can't just do energy efficiency projects, we can't just buy quite weak offsets. We really need to be dedicating resource into looking at carbon removals, both natural methods to do that and also man-made. If we step it down to the United Kingdom, we've got the same net zero target, but we've got interim carbon budgets that we need to meet on the path to 2050. London as a whole city, the local authority as a whole is trying to be a bit more ambitious. We want to get to net zero by 2030, but there is the caveat that is looking at operations only. So we'll come on to a bit more of that later on. So my organisation, Transport for London, we've got the kind of transport subsystem of the whole city. So we have to do, follow the same requirement, net zero by 2030 in our operations, but we want to go further. We build quite a lot of infrastructure, we manage a lot of infrastructure, so we want some more targets on our capital projects. And ultimately, that's what we have to deliver as TfL systems engineers, and whatever projects we're working on, in what capacity. And that's our picture, and we think we are trying to be quite ambitious at TfL. So in terms of TfL emissions, there's lots of ways to kind of slice and dice. This tries to show some of the emissions, really splitting between our operations in the middle. So this is what you kind of traditionally consider carbon emissions from our running our trains, the carbon emissions from the electricity consumption, from gas use in our buildings, and from fuel use from our vehicles. If we move to the left-hand side, we're then, actually, let's go to the right-hand side. If we move to the right-hand side, we're then looking at London's wider transport network. So all those private vehicles that we don't have control over, direct control at least, but we try to indirectly influence people's behaviours, whether that's through congestion charges, providing, good cycle infrastructure. Really, that 5 million tonnes of CO2 is what we really need to target. And then finally, on the left-hand side, where a lot of influence systems engineers have, is what's in infrastructure in the supply chain. Crucially, all the carbon that's associated with all the stuff that we build, all the materials that we bring to site, particularly concrete and steel. That's really where a lot of influence systems engineers could have. If we add this all up, Transport for London's annual carbon impact is, can't remember, I added this up earlier. It's about 8 million tonnes of CO2 per year, which if you work it out is about 2% of the UK's annual carbon emissions. So, you know, we're significant and we need to do something about these numbers. So when we look at our emissions in total, we've got lots of infrastructure here. So why do we need to, you know, start to manage all of this carbon? How are we going to do it? I'm going to start taking you through that. First of all, why we need to do it. You know, we need to reduce our carbon emissions. So that's sort of step number one. Not going to dwell on that. Step number two, reason number two, and hopefully this can try and remove any the sort of common misconception people have about carbon management, which is low carbon design must be more expensive. I must have to buy loads of solar panels. I must have to buy lots of expensive low carbon concrete, which just doesn't exist yet. You know, it's just going to cost more. But the UK in 2013 produced a document called the Infrastructure Carbon Review, which had a look at this and basically came up with a conclusion that if you do really good carbon management on projects, you've reduced carbon and you also reduce cost. And that's largely to do with the 4 steps on the right hand side. So if you're going to take anything away from this webinar, this is what I'd like you to take away. Carbon management ultimately is building nothing, building less, building clever, building efficiently in that hierarchy. Starting right at the top, when you've got your outcomes, your expected benefits from a scheme, you know, think as hard as you can about building nothing. You know, do you really need that scheme? What can you do to build as little as possible? And you can very quickly see how that's tied into how much your project is going to cost. When you start building clever, you're thinking about efficiencies, you know, streamlining delivery, as it says, minimizing resource consumption. And it's only really then that, again, you know, you're maybe going to design in low carbon materials, but that's not like first top of your list. And so that possibly tiny increase in cost is going to come later. And then finally on the list, build efficiently. So, you know, do things right the first time, eliminate rework as much as possible. And you can see hopefully how all of these things tie carbon and cost together. And so this is why we should do carbon management. It's not just about carbon, it actually makes project delivery much more efficient and saves money. In terms of what carbon management is, there is a publicly available specification published by the BSI, which seeks to provide a framework for carbon management within infrastructure. And there are, when it was published in 2016, there are 5 main points. First of all, having leadership. So is your, particularly at the moment, is your organisation committed to reducing carbon? Does it kind of acknowledge it as a problem? Is it willing to make some changes to make it all happen and to do better? Secondly, producing whole life carbon assessments. So hopefully that addition across the top line tries to demonstrate this. Very similar to whole life costs, in exactly the same way to a whole life carbon calculation. So you really understand where is your carbon coming from. You know, don't just make an assumption that it's going to be the electricity, for example, because once you do the analysis, you might work out actually all of the carbon coming from my concrete is what I really should be focusing my efforts on. So it's a really good way to start getting a better handle on your project. After you've got the numbers, you can start setting targets and baselines, you can monitor and report against it, and you can continually improve your process. So in a nutshell, that's carbon management. But with this particular guidance, when it was first published in 2016, you know, really, really useful, but we found very quickly that people weren't very good at taking a whole life view and looking at the full system. They take kind of small sections, they'd pick and choose which bits of carbon they'd quantify, and it was all a bit of a mess, and it really didn't end up with the right outcomes. If you're not looking at the full picture of the full system, you know, you're going to have problems at the end of it. You're not going to come out with the outcome that you want to achieve. So a 2022 update tried to target some of these changes, some of these issues. Really, first of all, looking at integrating carbon management into decision making. So it wasn't just an add-on, it can actually hopefully be seen as important as cost and schedule, and also procurement, because we all know the supply chain is really, really crucial. And on this as well, the introduction, sorry, let me start that bit again. With this as well, the full document was revamped to start having a much deeper focus on systems. So just this sentence in the introduction, for example, talking about the changes, we need to increase the emphasis on a whole life carbon approach, addressing the urgent need to decarbonize systems, networks and assets. So it's really, really exciting. I think I did a word count of how many times systems is mentioned in the new version versus the old version, and it's kind of tripled. So it's really exciting that they've put systems right at the heart of carbon management. So we can go into this in a little bit more detail, really how to do it, and it's you know, it's at the heart of it. Systems engineering isn't mentioned yet, but it is all about systems engineering. The Royal Academy of Engineering in the UK, as well as the Council for Science and Technology in 2020, wrote letters and gave papers to the Prime Minister's office saying that achieving net zero carbon emissions really needs a whole systems approach. And if you go through that paper, you can kind of start to spot the similarities. So first of all, recommendation 1, we need to ensure the net zero target is translated to all areas of government responsibility. So, you know, we're very familiar with defining system requirements and how we cascade them to subsystems. If we look further down in the document, we need to build a clear vision of the system required to achieve net zero. So I think we've got system architects on here. We know how to write functional descriptions. Next one down, we need to, oh, sorry, I realize it's going to be lagging behind my changing of the slide, apologies. So the third one is we need to be identifying, exploring system level issues, including synergies and trade-offs. So we know how to manage interfaces, where we deal with system risks and opportunities management all the time. And then if we look to the final recommendation, it says we need to establish a multidisciplinary operational group to support the development of our strategy. And basically, in other words, we need systems engineers to be looking at net zero. So none of these documents, they don't say systems engineering yet, but I feel it's only a matter of time, because all of that knowledge, all of that thinking is exactly what systems engineers do. Systems thinking, it is and sort of, you know, distinct from systems engineering, but we are the profession and set of engineers who have that knowledge, the tools, the skill sets already to really make this happen. And at TfL, it's really exciting that this is what we're trying to embed into our projects. So in terms of how we're doing with that, our journey is, you know, I've tried to see this very much like validation. We start at the smallest subsystems, and we you know, integrate that subsystem, and then you keep moving up until you've got your whole system, your whole network validated and tested end to end. And it's, you know, very similar approach to what we're trying to do with carbon management. Starting on a project, really kind of project level, driven by individual engineers who are very keen, very motivated around carbon. And moving into programs. So, right, how do we take thinking on a project and roll it up across the program when we're no longer thinking about assets and we are starting to get into system properties? How do we manage the carbon there? We then go, right, okay, so that was all theoretical. Let's actually do that for, not theoretical, but, you know, that's early stages. It's all kind of managed almost by desktop. Let's try and do it on a program in delivery, where you've got the complications of projects at different stage of the life cycle. Some projects might have a supply chain already procured in and on contract. Others might be at the start of feasibility, and you get those challenges in the program. You then go, right, okay, how do I roll this out to multiple programs and their different quirks? One which is highways, one which is rail. How do I do that? We can then turn to portfolios in delivery, so kind of major projects as a whole, highways as a whole, what else, our renewals portfolio as a whole, and then finally the holy grail is that's just carbon management's done business as usual across the organisation, and ideally my kind of vision is to do myself out of a job. If we can get there, you know, that would be great. So I'm going to talk through now a little bit 2 case studies. Bakerloo line upgrade extension being the first one, and this is that kind of program feasibility category. It's a program that we would like to pursue, and where we are investigating. It has been paused because of cost, but it's an example of really good carbon management in feasibility. So this is really messy London Underground map that I'm sure some of you will have seen before. And the Bakerloo line is the brown line, which kind of runs diagonal across the screen, as you can see there. So what we want to do is, first of all, upgrade the line, because we've got rolling stock from 1972, so it's quite old, and we're planning to run it for another 10 years, so there you go. And we want to extend the line. So upgrade and extension, so it's the acronym is blue, which is very convenient. And the intention here is to add 4 new stations through South London, and have a potential future option for a further extension. So if we follow our carbon management hierarchy, step number 1 is looking right at the top and saying, right, should we build nothing? And you know, for this exercise, when you're in feasibility, that's not particularly useful. So you can kind of say your baseline, your carbon emissions are going to be 0 tons of carbon. But it's always helpful to keep that in mind, because build nothing should always be on the table. That should be your benchmark. You should always work out, is what I'm going to build going to make the situation worse or better? And you can always, well, we need to get better at accepting that build nothing is a valid option, and it's something that we should have on the cards. Assuming, you know, that's not acceptable, and we should do a little bit of feasibility work to kind of actually have options to assess. We built we developed the first iteration of the scheme, so 4 stations and a new depot at the bottom there, Hither Green Depot, and that came out estimation of 800,000 tonnes of CO2 for this whole scheme over an operating period of 60 years. So this was including carbon from the concrete, to estimations of the amount of carbon from the track and some of the systems, through to the energy associated with running the line. So really trying to take that whole life approach. But we started to look at this from a carbon lens. And with that, with our do minimum estimate, with this carbon management lens applied, really trying to focus on building less and building nothing, we've been able to save, in our estimates, 28% of the whole life carbon, and crucially, save 40% of the total cost of the scheme as well. And there's a few things on the screen which kind of show you how you do this, and really it's going back and saying, right, how do we minimize what we need to build? What are our requirements? Challenging them, going back to the sponsor and saying, you know, as engineering, we don't think we need this, and you can kind of see the results of sort of reducing 40% in cost. And this is really stems from reducing the number of trains per hour. Going from 36 to 27 means we reduce 40% of our energy consumption. We don't need as many trains, so we could get rid of the whole depot. A really good example of building nothing or building less, depending on your system boundary. And we can make the tunnel shorter. So I think hopefully this really shows that using carbon as the lens for doing your value engineering can be really helpful. You're not worried about fluctuations in price, in, you know, inflation, and what your materials are going to cost, what your resources are going to cost. You're purely just looking at the physical scheme, because carbon is just a physical measure, and you're using that as a lens to conduct value engineering, and it's been really successful in the Bakerloo line. The second example we're going to look at is the next stage, which is going from a program feasibility to a program in delivery. And in this case, it's the Piccadilly line upgrade. So kind of similarly sister lines, also 1973 rolling stock. We're not extending the line, we're just upgrading it. So this program is currently in delivery. You know, we've committed to it. It's a £3 billion program, and we're getting in approximately 19 new metro rolling stock from Siemens. And we've got all the enabling works which have to happen around that. So depots and stabling, we need to upgrade our depots for the new trains. We need to put in one person operating CCTV systems. We want to take the chance to upgrade a lot of our infrastructure, so putting in extra low loss conductor rail instead of just low loss. And of course, there's a bit of signaling work to do too. The other really good thing about the program is we've got a separate systems integration function and systems engineers, which obviously work across the piece. So we've got, really good migration plans, hopefully, for the program, testing and commissioning. That's all managed as its own, almost separate sub-program. So in terms of how Piccadilly Line has done really well in carbon management, and we'll basically try and address it by going through the PAS 2080 framework for carbon management. So first of all, with leadership, the program is very lucky to have a program director who's very switched on to carbon. He's really invested in personally in carbon. He finds it a really like me, I guess, driving motivation for his work, forgetting my words. And so he's really advocated the systems engineering and project management team who are trying to drive through this change, and having that advocate right at the top, you all know it really, really helps. Integrating carbon management into decision making. This is a work in progress, but we're working with the project sponsors to really bring in carbon requirements into all of the gate reviews for projects. So it's not just cost and schedule on the table, it's carbon too. We've done whole life carbon assessments for the whole programme, so that the £3 billion worth of work. We've created whole life carbon assessments all in-house with a tool that we've developed, with training that we've provided. And yeah, we're really proud that we've trained up about 60 engineers on the programme to do those assessments themselves, because it means they really understand it, that they get what's going on, and they then understand how to use those numbers more effectively than if they were just given a report. They feel a bit more engaged with it, and it's worked really well on the programme. We're setting targets and baselines, which are now in our sponsors' instructions. We're trying to get into a flow of annual monitoring and reporting of these figures. So every year they need to come round and update those numbers and make sure they're properly engaged on them. We have updated our works information to include carbon management requirements within procurement. And of course, we're always trying to get feedback from our project managers, our engineers about, this is all new. How did that work for you? Okay, it didn't go well, right? We'll fix the training, we'll fix the tool. So we're trying to be as open as possible. So now turning to some of the systems engineering tools and skills which have really helped on the programme. First of all, we have the systems engineers leading integration of those whole life carbon assessments and management of the whole life carbon assessments across the programme. So it's been me until I stepped off the programme a few months ago, and my line manager who have been driving this through. And this is something we've now duplicated across our other major programmes within TfL with our systems engineers. So it's the same on the Northern Line extension. They manage the production of all of the whole life carbon models. Same Silvertown Tunnel, which is a highways project. Same on the Docklands Light Railway rolling stock replacement programme. So we've been able to copy this through and start to really upskill our full systems engineering team, which has been really exciting. What I really like is that we are treating system properties as system properties. And what I mean by this is that a lot of the time when you look at carbon assessments or you kind of approach a programme about traction energy, lots of people will say that, oh, that's the problem of rolling stock. And the rolling stock people will say that's the problem of power engineering. And what we've been able to do is say, no, okay, all the carbon associated stuff with traction energy, we're going to keep that under a systems property model, which the systems engineer holds and manages, and therefore they've got those links to rolling stock and power to really find those system opportunities to reduce traction energy, which ultimately is that system property, as is carbon. Carbon is ultimately an emergent property of the full system. Requirements management. I think I've touched on this already, so it's a bit of a repeat. We've now got carbon reduction targets within our sponsors' instructions, and our engineers are sort of all on top of requirements management, of course. And then finally, what's been really exciting as well is system and program risk management. So within our program risks, we now have carbon emissions held within there. Specifically the risk of legal challenge if we actually don't do anything about carbon emissions, and the cost risk of if we don't do anything to try and reduce our carbon emissions, if in future we're required to offset all of that, we're going to have to pay more money. So if we reduce the whole life carbon emissions of the program now, means we pay less in future. So it's all those kind of cost incentives that we're trying to get going. And secondly, what's been really exciting with risk management is that we are trying to manage carbon risk and opportunities directly alongside cost and schedule risks and opportunities. This is something that's worked really well to engage the project managers, as essentially now we've within our risk management tool, they'll have a list of all of their risks, so risk of rework, and then they'll have the columns for their impacts. So they have to quantify the cost impact of that, the schedule impact of that risk, and the carbon impact now. And that's really worked well to bring carbon right into the forefront. So yeah, something I'm quite excited about that we've been doing. So that's a couple of examples. What next? First of all, you know, we're making our way through up this sort of very long-winded validation chain, which is not quite validation, but you know, the analogy kind of works. We want to start moving into our wider portfolios. So we've done lots of carbon management now on our programs. I mentioned we've kind of duplicated it with systems engineers leading across our major programs. So we now want to bring all of that thinking in our major projects portfolio into our other portfolios, like highways is separate, our renewals portfolio is separate, our air quality portfolio is separate. So, you know, we're going to have to start thinking differently, perhaps where systems engineers don't traditionally have influence, but we know we need to start reaching out wider. And ultimately, of course, the holy grail is being able to quantify our whole piece. So we're getting there. We're learning. We're constantly improving. But you know, there's still lots to do. Still lots of tools to develop. And still lots of systems engineering to propagate. The wider piece around net zero, you know, it's not just about how you deliver projects well. We need to be looking at what the solutions need to be for the whole of London, for London as a system, not just a programme as a system. And I think this in particular is what really excites me about net zero and being a systems engineer at this point in time. Net zero targets, you know, that they are hard, they are challenging. And all these papers, you know, going back to the beginning, say that we need systems thinking to make the most of those opportunities. So what are we going to do to optimize our power and energy consumption? It doesn't make sense for London Underground to have huge amounts of power capacity, bus stations to have huge, bus garages to have huge amounts of capacity, the emergency services to have to install huge amounts of capacity. There is a huge amount of power sharing that we could be doing if we start thinking together and we start working out how all those systems currently interface, which is probably not at all, and how they should be interfacing, which comes back to that whole system design piece. Similarly, this thought bubble here, sort of traction energy and EV charging. One of the active opportunities we've got in this space is there are particular examples where we have London Underground depots right next to bus garages. There's literally a road in the way, and all we could do is just basically throw a cable over the fence, and there, you know, we've immediately electrified a garage, and it's proving surprisingly difficult. And I think it's because we don't have that system vision. We haven't worked out what the model is. We haven't mapped out what all the system implications are and how far that opportunity could spread. Is it just going to be garages? Can we start moving to EV interfaces as well? How does that work in a commercial sense? So there's loads of opportunities we're just not exploring yet, and I'd like to kind of knock on the door as a systems engineer and make those happen. Lots of other fun stuff happening. We've got waste to heat recovery. And by this I mean that the metro system, London's metro system in particular, is very warm. It's always very hot down there, and that's basically free ground source heat that we could be providing to people. And again, for whatever reason, you know, we're getting stuck at commercial issues, we're getting stuck on technical issues, and again, it's bringing together these subsystems which traditionally haven't spoken to each other, the heat network and London Underground, and why can't we get systems engineers to work out how that can function? How can we get an integrated heat distribution network across areas of London which take into account residential buildings, commercial, and the underground network itself? So again, really exciting system opportunities. And then finally, it's not just carbon that we need to be worried about. We need to be adapting to climate change because some amount of change is inevitable, and we need to be thinking about the other aspects of environment, biodiversity, for example. And those, much like carbon, are also system properties, probably maybe less so climate adaptation, but biodiversity certainly is. That's a really complex system. You know, that's not man-made, that's nature's system. So I haven't even thought about how we start getting to that. But I think if we start expanding what we mean by systems and systems engineering, you can see how you start to get a really exciting scope of work in future, or at least I do, and hopefully you kind of see that too. Right, so what should you do? So I've got my requirements cascade, you know, right from what are the planetary boundaries down to me and my system and my subsystem opportunities within Transport for London. So I think hopefully provided a little bit of the framework for you today to start thinking about, you know, what's your requirements cascade? You know, we're all on Earth, but you know, what are your country's requirements? Where's your country trying to go? How about for your local area, your city? What are the ambitions there? And then finally, you know, to your organisation and your system, what can you influence on the programs that you're currently working on? How can you take in some of these principles? And crucially, that kind of 4-step carbon reduction hierarchy. You know, if you take anything else away, if you can remember, build nothing, build less, build clever, and build efficiently. Don't need to worry about any carbon numbers. If you do that, you'll stand yourself in really good stead to do really good value engineering that hopefully can save carbon as well as cost. So I think hopefully I've kept to time there. I've tried to keep on top of it, but obviously looking forward to discussion and happy to take any questions.
Well, thank you very much, Jane. That was really interesting. So yeah, first of all, thanks. And I don't know, before we go into questions, I think it's important to say thank you for that. You've touched on some really interesting and important issues there. You know, covering, you know, what is the carbon challenge down to what TfL is doing. It's quite interesting to see, you know, some real examples, particularly the Bakerloo line was interesting, and then really what TfL are doing, you know, next, and what the future might hold. So that was really interesting. Thanks. So we'll come on to questions, but first of all, I don't know if everyone would like to come off mute very briefly and give Jane a brief round of applause for that. Thank you very much. Okay. So if people want to pop questions in the chat, we've got a few minutes left. So perhaps if I kick off very briefly, Jane, and then I'll go. I know I think we've got 2 more lined up at least. I was interested in just if TfL had given any thought into sort of how they traded off the impact of decisions between the projects. So for instance, those decisions that were being made on the Bakerloo line, you know, that will change, you know, the behavior of cyclists potentially and so on. And then, you know, once you come up levels, yeah, how do you do that? And is there any thought to sort of trading carbon within TfL between projects?
Yeah, it's a really good question, and it's one that I've raised, but I think with all the negotiations we've had, we've had lots of funding issues with those on the call who don't know. It's something that we haven't been able to bring up, so I'm hoping to push that onto the agenda. But I think we know increasingly that paying for carbon offsets is something that we're probably going to have to do, particularly because we've got this net zero operational target in 2030, and there are some residual emissions, for example, gas heaters in big depot spaces that we know we can't deal with. So how do we do we pay those offsets externally, or do we start an internal carbon trading system where one project, where every project, they quantify their carbon emissions, and that has a certain internal price, and we put it all into a funding pot. So I can't remember it off the top of my head, but I know there are particular case studies. I think actually National Grid in the UK. So the electricity grid sort of manager within the UK, I think they've got that internal pricing system. So there is definitely precedence for that, and I think it's really interesting. Concentrate investing back within yourself, as opposed to just paying that money to externally to at the moment to offset schemes which aren't very good. So definitely something that's on the cards, and I know our corporate environment team is very keen to pursue that.
Okay. Thank you. Bruce, I'll go in order of the chat. Bruce, people want to come on and ask the question themselves?
Hi, Jane. That made my day, that presentation, because it's such a huge problem and there's so little really being done, and this is something real. But you're running up into problems in running a cable across a fence turns out not to be as easy, and I'm not surprised. And I don't think it's just cultural. I think there are issues about, for instance, who pays for business loss when there's power interruption and that sort of thing. And getting those untangled is horribly difficult. And it normally involves someone quite senior stepping in to make it happen. And I'm just wondering how we do that. I mean, systems engineers, I don't think, can do that. I think that's what mayors and the like do, and CEOs. But I know quite a lot of people who worked for TfL during the Olympics, and they are fiercely proud of what TfL achieved during the Olympics. And for a few weeks, things that were impossible became possible. And if only we could find a way of bottling that and using it for the climate emergency. So it's two parts. It's a bit unfair. What do you think?
So on your first part, yeah, I agree. There's lots that systems engineers can do to help that wider piece, like how do we actually roll this out sort of at scale? Can we roll out these opportunities to connect the London Underground network to other networks at scale? And then, yeah, there's the softer piece of, right, someone's going to have to make a decision on this, some call about what the commercial agreement's going to be. And, that's sort of out of our hands. But it kind of comes on to your second point about how we move things forward at kind of pace and try and achieve the impossible. And a lot of the work that we're doing beyond being kind of technical work on programs is the piece around training and around comms, which is, like to just kind of crack on, but there's, at the moment, I think we're reaching a tipping point where people are starting to get a lot more enthusiastic about the climate and the environment. And we're starting to get people, not just in engineering, but across different areas of the business, including things like legal and commercial, that everyone has a role to play in it. And if you can find out what you can do within your role, so I've talked about what systems engineers could be doing. If we have the same within our commercial team, if we have the same in our legal team, and everyone kind of slowly chips in and does what they can to help in this space, and they understand why we need to do it and how it helps, then I think, we can move a lot of this forward. So it isn't just the technical side, it is that leadership side, it's that softer side, it's the engagement. But I think we're getting there.
Brilliant. Thank you. Okay.
Thank you.
Right. Next on the questions, Alexandra, would you like to ask your question?
Sure. Thanks, Jane, for your presentation. It was really interesting and thought-provoking. I think my question, and from what I read, the next couple questions kind of touch on a similar topic of just broadly speaking, kind of balancing that providing public transportation is one of the best things we can do for carbon emissions because we're getting people out of cars. I'm in the US, so we're mostly getting people out of cars, not necessarily transferring from bike to bus. And so how do we balance that when we're trying to challenge ourselves as agencies to reduce our own carbon footprint, to electrify our buses, to make the most sustainable new depots or new buildings possible? And then, so specifically in your Bakerloo project example, kind of when you put together the build nothing, having that be zero emissions, but that doesn't account for all the people who will be riding that train one day who are presumably driving in cars. I don't know the situation there, but presumably driving in cars right now. And so it sort of stacks the deck against them. And then wondering, when you did make that decision to reduce service, which we know affects the competitiveness or attractiveness of transit, did you kind of offset those carbon reductions with potential increases associated with like attracting fewer riders?
Yeah, sure. So I'll try and take those in turn. So I think the key thing with the numbers, and I probably should have made it clearer at the bottom, was that those figures were purely looking at the whole life of the infrastructure. What we hadn't looked at is and I could have gone into it a little bit more in my presentation perhaps, is what you're describing as those wider benefits of building that transport network. It doesn't exist in isolation. You have all the system effects. Crucially, with transport, you're looking at mode shift. And with what's really interesting for London, which is very different from America, because public transport is still very sparse, so any line that you put in is going to get significant numbers of mode shift. In London, we're a very different environment where it's an amount but compared to London, where we have already a very dense city with reasonably good public transport already, the amount of mode shift is actually not as big as you expect. So yeah, particularly for the Piccadilly line upgrade, for example, I think for all that upgrade, increasing TPH, I think it was something like expecting mode shift of like 5%. I can't remember the exact figure, but it's low, and that's because so many people already take public transport. It's quite a small city. And so that's the challenge we have. It's working out, right, how does the benefits case actually work now? But it's a lot of on the cost side, we base our business cases on growth. So if we increase TPH, we can bring more people into London, and then you get into the complicated question, which I haven't seen solved yet, which is how do you calculate the carbon emissions of the carbon growth shift of someone who lives in the sticks and drives everywhere and now lives in the city. So it's all a question about where you draw your system boundary, and it's that benefits piece that I haven't gone into so much today, but it's a real challenge sometimes. But our city planning team are getting into that. So hopefully that answers quite a lot of people's questions on the call. It's quite challenging for London to pull out that wider system benefit, and that's the whole life piece that we're trying to get better at. So yeah, could have had a slide on that, but I have not. Hopefully that helps. It's an interesting problem.
Brilliant. Okay, thank you very much, Jane. We've got time for one more question. I think Tim, I don't know if you want to ask your question, or Timothy through.
Okay. Well, there was quite a bit on the same sort of theme of some of the things which were being done in the Bakerloo line example. were to reduce the capacity of the system, such as reducing the number of trains, to reduce the size of the tunnel, to reduce the size of the station, all of which, reducing the size of the station reduces the length of the train you can operate. Reducing the size of the tunnel would preclude you from ever considering any kind of double-decker train to get more capacity, those kinds of things. Is it possible that by trying to optimize for the carbon situation, it might be tying up knots which mean that the system becomes quite inadequate for the demand in 50 or 100 years' time, which in the TfL you'd be quite familiar with the problems of the 100-year life cycle.
Yeah, no, you're completely right. I guess it's that classic question of, what's over specifying and what's allowing for the future. And I know our team, for example, there's a reasonable kind of overrun length at the end of the proposed extension, just in case in future they want to go for a further extension, add more stations later on. So there are those elements built in, and so they have tried to work out, right, how does this look like in future. In terms of your other point, it definitely comes down to the fact that London and the existing lines are already so constrained. So the Bakerloo line extension would feed into the existing running tunnels under London. So the cost and complexity of eventually widening those existing tunnels to be able to fit, double decker trains, that's going to be, a huge challenge on its own. And in terms of the station length, I think the length was kind of kept as is, in line with existing stations. But it was a case of making more efficient use of more of the volume as opposed to the length is probably a better way to describe it. The original design, they were trying to work out, right, is this incredibly, inefficient use of space? How do we compress the volume of that station box down? So that the length is sort of as is. So yeah, completely take your point. I think we've tried to work out, right, over a longer period of time, what do we need? But we still have the wonderful constraints of London Underground's sort of 100-year-old transport network that we still have to design with.
Thanks.
Okay. Well, I think we'll leave it there. Thank you very much, Jane. Again, your time's really appreciated, and I'm sure everyone's taking a lot away from that. I know I certainly am. Hoki, I don't know if there's anything else we need to cover, or should we just draw things to a close there?
No, well, we can close out, and well, thank you everyone for your time, and thank you, Jane, as well, for a fantastic presentation. And again, this recording will be available on our INCOSE TWG YouTube channel, probably in a few days' time. So Matt, don't want to spoil your presentation, but do you want to give a very high level of what you will be presenting in person in October?
I'm trying to remember what I said I'd address. Yes, very high level. Some reflections and thoughts really on the use of hybrid rail vehicles as part of a discontinuous electrification approach, and whether that's the solution now. Now we, particularly in the UK, have come to the conclusion that electrifying all of our railways is a very expensive and time-consuming activity. Yeah, at a high level, it's focusing on the use of hybrid rail vehicles, so battery-powered and 25 kV OLE vehicles as part of transforming railways for the future.
All right, fantastic. And well, this will be the end. And thank you very much. And I'll stop the recording. Thank you again.